Right guys, today you're going to work on estimating the area under a graph. And another word for area under a graph would be distance, as we mentioned in last lesson. Because if you look at it, we've got the height is still going to be the speed, and the length or the width is going to be the time. So distance, as we know, is speed multiplied by time. Area equals height multiplied by width. So that is why when we're calculating the area under the curve, we are also actually calculating the distance travelled. One key point you need to note from this, if you look at my question from here, estimate, well, first of all, we're only getting a rough answer, so all your answers are going to be slightly different, but also it doesn't tell us how many shapes we should draw underneath the graph, because if you look at it, this shape underneath the graph, don't know what to call it. But what we're going to do is we're going to split it up into squares, rectangles, triangles, trapeziums, whatever is the easiest. But if it doesn't state so, a minimum, at least 3 areas you need to calculate underneath it. So if we can divide it into 3 different shapes, find the area of each of those shapes, add them together, that is an estimate for the area underneath a curve. Right, we are going to divide this one into 3 shapes. The first one I could see, if I join the 9 to the 8 here, that's going to be my first shape. So it is the 1 all the way up to the 8. That's going to be my height. But it has another height over here from 0 to 9. We're going to call that shape 1. And shape 1 is going to look like this. If I turn it to the side, if you notice, it ends up, you've got 2 parallel lines there. You've got a height, a perpendicular height that is, and you've got this slant height. So what you end up with is actually a trapezium. So my trapezium looks roughly something like that. And make sure you're drawing rough sketches of it like so, and fill in everything you know. So this longer height was the 0 to 9, so that's 9. The shorter height was from 0 up to 8. And lastly, we need the perpendicular height. So that was this height here. So it's going from 0 to 1, so that's just 1. Now area of trapezium, we looked at the last lesson. It is A plus B, so 9 plus 8, multiplied by the height, and then divided by 2. Make sure you note that down for yourself. So you've got A plus B multiplied by H, and that's all divided by 2. That is your formula for area of a trapezium. So the area of this trapezium is going to be 17. 17 divided by 2 is 8.5. So that equals 8.5. I'm going to circle that because we'll need to do something with that later on. That's just one area. We need at least 2 more areas. So if we look at this one here, we could go from this point down to the top of the 5, I think. And that's pretty much on the curve there, so that's very accurate. If you look at the previous one, we had a bit of a gap here. So this was a bit of an underestimate. We left this little space out. Right, our second trapezium is going from 0 up to, it's roughly about 8. I'm going to go with 8. So we've got height of 8 on the longer side. And we've got, that was Miss Fairbank knocking on my door disturbing me. Can you believe that? Right, we've got a height of 1. And then on the other side, the length here is going to go from 2 up to 5, or sorry, from 0. Apologies. So this is going from 0 up to the 5. So that's a length here of 5 units. trapezium, so we're using the same formula as before. A plus B multiplied by the perpendicular height, which is 1, divided by 2. So our answer to this one is 13 divided by 2, which is 6.5, and that's the area of this trapezium. So that was shape 2. And our final shape, so we need to get all this area down here, but if you notice, it's pretty much a triangle. So we're going to draw a triangle for this one. And again, it's pretty much on the line, so it's just a slight underestimate. We're leaving a small bit out, but again, if you remember, we're only estimating the area, so it might be a little bit below it. This is shape 3. And our height for shape 3, I think we're going to be as accurate as possible with this one. We're going from 0 up to, this is roughly, I'm going to go with 4.5. So 0 up to 4.5. So this triangle, there's our 0, we're going up to 4.5, so that's a 4.5 length. We also need the width. The width goes from 2 to 3, so that's a 1. Area of a triangle is 4.5 multiplied by 1 and then divided by 2. So that area is 2.25. Now you've got the areas of these 3 shapes. We said we needed at least 3 shapes. Your final step is to add them all together, and that would be an estimate for the area under the curve. So it's 8.5 plus 6.5 plus 2.25. This is going to be 9, 15. 15 plus 2.25 is 17.25. So I've gone too fast on that. Do rewind it, look at it again. The key thing is getting those shapes right. As I said, you need at least 3 shapes. The more shapes you draw underneath the curve, the more accurate you're going to be. So I could have drawn a trapezium there, I could have done another one here, and you would have closed down that space there. So you're getting more and more accurate the more shapes you draw. But if it doesn't state so, you draw at least 3 shapes, calculate 3 areas to get the whole area underneath the curve. Do one more example, because if you notice with this one, this one's a bit wider and this one has a belly on it. So what's going to happen with this one, we're probably going to go slightly above the curve and therefore have an overestimate. We're going to go with 3 shapes again on this one, I think. Try and make them as accurate as possible. So I think one could be here actually. So that's going to be my first one. Just because this curve pretty much crosses where these boxes cross over. I don't want to take this one because that's going to be some sort of messy decimal. My other one could be this one here, where again it crosses where the boxes touch. So that would be exactly 5 when I'm recording it. So that's going to be my second shape. And my third shape then, this touches these boxes nicely up here. So I've got my 3 shapes. The bottom one, be very careful with that. It's not a triangle because you've got this parallel length here. So shape number 1 looks like this. So the shorter length, that's about 0.5. This longer one is nice and easy, it's a 1. And then our height, we're going from 2 to 3. So that's just a 1. Our formula is 0.5 plus 1 multiplied by the height, which is 1, and then divide it by 2. So this is a trapezium. That's 1.1. 1.1 divided by 2 is 0.75. My second shape looks like this. So if we turn it on its side, the shorter parallel length is here, so that's a 1, and the longer parallel length is here. It's gone from 0 up to 5, so that's a 5. If you can't see it from here, turn it on its side, you've got parallel lengths there, and actually I forgot to draw my line here. That completes the trapezium. So there's the trapezium here. So if you see, it goes above the curve, so this one we're going to be overestimating it because we've gone beyond the curve. And lastly, the height this time, be very careful with it, is from 3 to 7, so that's a 4. And again we're looking at area trapezium, so it's 1 plus 5 multiplied by 4 and then divide by 2. This one is going to be 5 times 4, 6 times 4, which is 24, divided by 2 is 12. Again, pause video, rewind it if you need to. Our last shape is shape 3, and again it's a trapezium. We're going from 7 up to 5, so that'll be one of our parallel heights or lengths. And this is the slant height. Again, it's gone slightly over the curve. That's okay. It's an overestimate. All we're looking for is that estimate. So our trapezium looks like this. We said this shorter parallel height is going from 7 to 5. 0 to 5. So that's a height of 5. Our other parallel length is going from 0 up to 10. So this is a 10. And the perpendicular height is 7 to 10, which is obviously a 3. So we've got 10 plus 5 multiplied by 3, and that's divided by 2. 15 times 3 is 45. Half that is 22.5. So there are the 3 areas. Add them up, and that is your answer for an estimate for the area under this curve. So it will be 12 plus 22.5 is 34.5, plus this 35.25 is the area underneath the curve. And as we said earlier, because we went slightly above the curve this time in both occasions, that would be an overestimate if you are asked for it. Have a go at the next worksheet. Note that on your worksheet it asks you for the gradient, it asks you for the rate of change, acceleration or deceleration, so that is gradient like we looked at last week, and then it asks you for a distance or an area. So distance or area is this, it is area underneath the curve, and go with 3 shapes, 3 areas, unless it states otherwise, but there are some hints on the worksheet. Rewind this and look at it again if you do need to do so.